Hello everyone and welcome to Mathematics. So today's video will focus on this chapter, differentiation, and here's everything you need to know on the applications of differentiation or the K-but questions of differentiation. For differentiation, you need to learn 4 types of applications, right? So the first type is tangent and normal. So let's say we have this curve and then we have this point. So we need to consider the line where it intersects point P but not the other parts of this curve, right? So this line will be known as the tangent. So there are 2 things we need to remember. The first thing is the gradient of tangent, or m, is equals to dy over dx. The gradient of this straight line is dy over dx at this point P, right? And then there's another line we need to consider, which is perpendicular to this tangent line, okay, or 90 degrees from this tangent line, which is the normal. Alright, so this is the second thing we need to know, the gradient of normal. Usually, I discourage students to memorize the formulas, okay? Instead, I encourage students to understand where does the formula come from. Okay, so we need to go back to our last year's chapter, Chapter 7, Coordinate Geometry, where we learned that for 2 lines which are perpendicular to each other, like for example like this, their product, sorry, if we multiply their gradients, it will be -1. Okay, so now let's say we have m1, which is dy over dx, and now we need to find m2. So if we want to find m2, what we need to do is just move this to the other side. So -1 over dy over dx, same thing as here. The second application is turning points. So these are the points where it changes the graph direction. So one of the examples is the maximum point. Okay, as you can see, right, before we reach the point, the graph moves up. Then after we reach this maximum point, it goes down. So from up to down, right, changing the graph direction. Same goes to another example, which is the minimum point. So this one is goes down and then later goes back up, down and then go up, again changing the graph direction. Alright, so now imagine we are not given the graph, okay, but we are given a few equations, and the question tells us to determine whether a point is a maximum point or a minimum point, okay, without the graph. So how do we solve this question? So we have 2 solutions here. One is the tangent sketching method. Okay, so for the detailed steps, I will explain it during the questions discussion videos, right? But basically, what we need to have is just 3 values. Okay, so the first value is the gradient before we reach the maximum point. Okay, somewhere here lah. The gradient of this line before we reach the turning point. And then the second value is during the turning point, and the third value is after the turning point. Okay, these 3 values, but we don't focus on the values, but focus on whether the value is a positive or negative. Okay, so for maximum, it will be positive. So positive means goes up. 0, later I'll explain why. Negative is goes down lah. So up, 0, down, which is a maximum point. So for minimum, it will be the other way around lah. Negative, or means goes down, 0, then positive, or means goes back up. Alright, but personally I would recommend the second solution, which is the second order differentiation. So technically it's the dy dx that we are differentiated from y, right? Then now we need to differentiate again to get d square y over dx square. Okay, so the value, if it is negative, then it is a maximum. If it's positive, then it's a minimum point. And there's another property I would like to share to you all for maximum minimum, which is these turning points are also known as the stationary points. Okay, reason is because these points are actually, I would say that the tangent is parallel to the x-axis, or meaning m equals to 0. So let's say if I draw tangents for these 2 points, right, it's actually a horizontal line. So for horizontal lines, their gradient is always 0, right? So, sorry, and also we have learned that from the previous application, m is equal to dy over dx, right? So if their gradient is 0, this means their dy over dx is also 0 for both minimum and maximum point. Okay, so this is the thing you need to know lah. For maximum and minimum points, their gradient is always 0. dy over dx is 0. Which is why when I was explaining the tangent sketching method, here there's a 0. Because during this point, both of their gradients is 0. So now you may be wondering, hey, is that a point? It is stationary, but it is not a turning point. Yes, there is, which is known as the inflection point. Okay, example is here. So please remember this one, because most of the questions or in textbook or exercise rarely ask this inflection point, so students might gradually forgotten about it. But here, please remember lah, because this one might be a potential question in SPM, right? So for inflection point, how do we identify using tangent sketching method is this. Okay, so this one is positive, 0, positive, means going up all the way, or negative, 0, negative, going down all the way. So you can see here, right, before it was going down, then we reach the inflection point, means the gradient is 0 lah. That's why here there's a 0. Then after that, it goes back down again. So that's why it's negative here. So you can see that goes down all the way. This one is an inflection point. Okay, and the second method, second order differentiation, is basically if the value is 0, then it is an inflection point. So this one is just how do we find a maximum point or a minimum point or an inflection point. But sometimes for certain questions, we need to find the maximum or minimum thing for a real life scenario, okay, real life application. So these are the I would say 3 main steps to help you all answer these kind of questions. Okay, so the first one is change all the unknowns to one unknown. Okay, let's say we have x and y in the situation. So we need to either change the x to y or the y to x. Means at the end, only one unknown remains. Okay. Second step is after we have an equation from here, then we differentiate to become dy over dx, and we put equals to 0. Reason is because the aim is to find the minimum or maximum quantity. As you can see, the characteristic of minimum and maximum points, dy over dx is equal to 0. Okay, so once we put this 0, then we can find the x or the quantity that the question wants lah. Then lastly, we need to find the second order differentiation. Reason is because I want to identify whether it is a maximum or minimum point. So if positive means minimum, minus means maximum. So to memorize the steps, I use a different way. I feel it's quite deep, but y'all can choose either you want to follow or don't want to follow lah. Okay, so it's up to y'all. So the way I would memorize is, so sometimes for some choices, a lot of choices given, but you can only choose one choice, right? So here, one unknown, here for my side is one choice. Then second one is, for the choice that I have made, I make sure I have 0 expectations. So 0 expectations from my side is dy over dx equals to 0. Then later the choice that I've made, then I see is it a positive impact to me or a negative impact to me. Okay, so here would be finding this second order differentiation, and then to see whether the value is positive or negative. So that's how I memorize lah. Third application is rates of